Hi, good morning, everyone. In this webinar, we'll be discussing Revit 21 and also Advanced Steel and the robot interaction. For those of you that are not familiar with Autodesk and the AEC collection, just like to focus very quickly on the platforms that are available within the stable. So you'll find over here we're going to look at which steel sections to use. It's very specific in Revit. Just quickly composing your model in Revit and the workflow between Revit and Robot. How does that work? And then between Revit and Advanced Steel. And then we'll field any questions if I can answer them. Otherwise, I'll endeavor to find the answers for you as best I can. Answer them as best I can. Right, so the AEC collection is really a license that includes all of these licenses. And within that, there are various platforms that interact with each other. We will find Revit, which is the BIM modeling platform for Autodesk. BIM is a very specific modeling culture and methodology. It's a building information modeling. It's applicable across the entire life cycle of a project. So you'll find all your big projects overseas are managed by BIM protocols. And within the Autodesk stable, the platform that's used to model that up, Revit is the main one. It's where everybody collaborates with each other, the architects, the structural engineers, the mechanical engineers, everybody collaborates in Revit, and these models are federated. So typically you'll find that it is brought into Navisworks Manage for clash detection and for advanced coordination and 5D analysis and so on. Navisworks handles these large files very easily. And clash detecting is also some online BIM 360 workflows that is essentially the equivalent of Dropbox, but it is much more secure with the software in the sense that the transactions are managed in a different way than, say, Dropbox or VPN or anything like that. And also it's the only platform that allows you to collaborate in real time. So that's really just the BIM side of things. There's some workflows between Civil 3D, between the civils guys, and InfraWorks as well. So these are the sort of main products that are used. But then we've also got some verticals and some items that bolt onto this. So you'll find that we've got Advanced Steel. Now this really is your typical AutoCAD, but on steroids. This is what 3D steel detailing, CNC generation, code generation for your machines, automated sheet layouts and so on, specialized joins, but when drawing in it, it's very much like AutoCAD. So you do need to understand AutoCAD to be able to work with Advanced Steel. It's very much a 3D platform. And then we've also got this Robot Structural Analysis Professional. So Robot is the equivalent, Marcus, I know you're familiar with Sumo, so Robot would be it would be analogous to what Sumo is to Procon. That's what Autodesk has on that side. You can, at any time, you can go and have a look at the collection and also find some further information on this. So you'll find that the Autodesk AEC collection, you can see all of them here. And if you want to try trials of them as well, then you can download them from the website, try them for 30 days. So if you want to try out Robot before you buy it or Advanced Steel, you're welcome to do so. And I think maybe because you are specialized and you might be looking for further information, let me also direct you to Autodesk University. So if you're not familiar with Autodesk University, I'd like to just make you aware of this. It focuses around Las Vegas, where they've got a yearly get-together of industry experts from around Gert, so there's a question, can you start your design in Robot structure, or is it analysis only? No, you can draw things up in Robot as well. Typically it is drawn up in Revit to start with, and then brought into Robot. So what you'll find over here is that it's a great question, yeah. So something like a parking ramp, for instance, which is traditionally very difficult to model up in Revit, and to integrate into the structural model that you need to analyze. That kind of structure you can more easily generate in Robot than within Revit. So there are various ways and means in which the structural model is set up, but sometimes Robot would be the modeling platform of choice simply because Revit isn't able to model that in a way that makes sense to the structural model. So in Autodesk University, you guys will find the latest workflows that people around the world are using. And it's essentially like a university first year standard where you'll find some great videos and so on, presentations on how to integrate the platforms that you find online. So if you don't get the answers that you find within here, please go and have a look at Autodesk University as well. It's over and above the help files. It's actually showing you what in the real world what the experts are busy doing and how they use Autodesk software. So please remember Autodesk University. It's free. You might just have to sign in to view it, but it's free to sign up. And so this would be a great further step for you to go and have a look at. There are even some further workflows where you'll find that Dynamo, I don't know if you're familiar with it, and so especially in the modern era, you'll find that we've got these sort of interesting structures that can be created. And there you can see how the automation, so some of these classes also you'll find online on Autodesk University. So when you find some really interesting structures, how you can use automation using Dynamo, which is a relatively easy visual programming language to understand, then you can also start iterating through the structural analyses to get to a preferred solution, and also to the geometry using advanced steel and all sorts of. So there's a big world out there. It's very interesting, but also note that that is part of the AEC collection as well. And so you'll find that you've got Dynamo with your Autodesk platform, Dynamo Studio. Okay, so that's just, if you, like I said, you guys are going to get this license, so you're going to have these licenses available to you, and that's perfect, because then you can, if you wish, you could supplant, if it works for you, you could supplant Sumo with Robot. The other platform that you might be interested in also is Rebar, and there they use AutoPads is the Procon solution, but in Revit is the go-to for rebar creation, and the rebar is created in 3D. So it's not possible to draw rebar as 2D elements within Revit. So everything is in 3D. Go to the next slide. All right, so first of all, with regards to sections, there's been a big change between Revit 2021 and 2020. When you go online, you'll actually find instructions on how to download this. So after you install Revit, one can go to this page over here. Revit Rebar is amazing. Okay, there's very specific ways in which you can set up the schedules for rebar bending as well. So I do have a template on exactly how to set up that for South Africa. So if you're struggling with your rebar schedule, please give me a call and I can help you out with that. We can just cut and paste the schedule across onto your project so you can make sense of that. And here you can see where you can download content for Revit 2021. So after you install Revit 2021, then you have to go further. You have to come to this web page and download specific content. So we do give instructions on how to extract the zip files to extract onto the libraries. And if you scroll all the way down, you'll find that we've got our South African content over here. So both family templates, if you're not familiar with them, that's how we start families. And then we've got the libraries over here as well. And it's the libraries really that contain our rebar shape, but very specifically in the steel industry, the steel sections that are available for South Africans. It used to be that we used the British shape codes because they were closest to the South African shape codes, but Revit has evolved and they've now got these steel sections for us as well. What it looks like when you go and have a look at it, I've got mine installed in D drive simply to save space. I must apologize, I've just installed the software again yesterday. I ran out of space when I was busy working on a project and then I installed the software quickly yesterday. But anyway, so here we've got our, so this is the typical sort of installation directory that comes with Revit. It's got your family templates, your IS files and your libraries, and in the library, interesting. So once you install the South African content, you'll see two things, and it's different from previous Revit. You'll have your English library, in which you'll find your typical families, including the structural columns and the structural foundations and the structural framing, boundary conditions. They're kind of ubiquitous. But just note that most of the elements are in the structural equipment as opposed to just columns. These are architectural columns, these are structural columns. So always going to have a look at the structural stuff there. However, with the South African library, what you'll find is that there's some extra content over here, including our rebar couplers, our rebar shapes. So you might recognize some of these numbers over here representing the rebar shape numbers. And then we've also got all the shape codes, and then we've got our rebar couplers, and then we've got two over here, structural columns and structural framing. When you open the structural columns, you'll see there are round bars and square bars. Those are simple, but then in the steel library, you'll have your South African specific library. You'll only have this if you download that extra content. So what we've got over here are steel sections that you should be able to buy from your local supplier. And why this is important, I might show this to you with reference to one of these files when we open it up just now. Note that you've got a family, and then below that you've got a text file, and the text file is what contains the information for the steel shapes themselves. So it will read the properties, and then ultimately it will come out with the information. The last parameter that you'll see here is called the section name key. That's important, you'll recognize it in a moment. And that would then be this piece of information there, and that piece of information there. The other information includes things like your area and so on. But very importantly, is to understand that you shouldn't be editing these sections because they are set for South Africa. So usually when we work in Revit and we want to duplicate a family and change the size, I would not recommend you do that to these families because this is what you get from the suppliers. And if you start editing that, not only will the structural analysis be incorrect, but the, how do you say, the, you wouldn't be able to buy it even. You know, you would have to substitute it with something else. So Just to save on time and to make it simple, I've done a very, very simple little model over here. It's got 4 columns, isolated footings, some beams, and then a structural floor on top of it. It's pretty easy to model something like this up. It could be multi-story. As you take it multi-story and you start doing the analysis assignment, it will get heavier on the computer. You must also have a nice strong computer to be able to do this. But this is really just modeling up something very representative. What happens when you model something up in Revit in 3D is that it also sets up an analytical model. And here you'll see just that the model elements have been switched off, and that I've done 2 things over here. I've completed the structural model, so automatically within your Visibility Graphics overrides, for instance, there you find your analytical model categories. If you look at your nodes, so these are your main nodes. You'll see there's quite a lot that goes into this, but if you click on one of these analytical nodes, you'll see that it is connected. And there's various ways in which you can work around specific problems with this model, but ultimately you want to set up a sort of a matchstick model that represents the physical model as closely as possible. It's never going to be perfect, and there's an engineering approximation, obviously. But this is the structural model. You'll find that you've got your columns. Within the columns, you'll find that you've got your, how did you get the nodes? Okay, so that is the Visibility Graphics override. They call it an instance property of the view on the right-hand side over here. You'll see that every view, when you select nothing, if you select nothing, you press escape either twice or modify twice. You'll find it at the top of the page over there. When nothing is selected on the screen, the properties that you'll see on the right-hand side there, the Visibility Graphics overrides is an instance property of the view itself. So I've done 2 things over here. I've switched on the analytical model. And really all that it's doing is in your Visibility Graphics overrides for this view alone, you've got the ability to manipulate the model categories or to override them, to switch them on and off, or to change the display, the model categories, which are your physical beams. So if you look at the other view, sorry if you're going into a long-winded explanation over here. If you look at this view, if I select a crossing window across the pillars, you'll see I've got one element that's being selected over here, and that's the structural column. However, in the background, you switch on the analytical model, so I can either click on this little button over here, or I can go to the Visibility Graphics overrides for the view. Remember, select nothing or press on escape twice, modify twice, go to the Visibility Graphics override. There's a shortcut for that. It's Victor Golf or Victor Victor. You click on that item over there and you'll find that you've got your different categories. So your model categories, that would be this column that you see on the screen over there. The analytical model categories, which is currently switched off, that will switch on if you toggle this little icon at the bottom of the screen there. That's how you switch your analytical model on. Now that this is done, you'll see that the node that I've attached to the floor is showing up, but also in the wireframe model, it's very easy to see that you've got this analytical model that's sitting inside of the structural model. In classical theory, we would expect this to be the neutral axis, but it isn't. You can offset the physical element from that analytical model, and so it will be an engineering approximation to some degree, within 5 or 10% or whatever. If you find that the results don't make sense to you, you might have to adjust the analytical model to represent the physical model more closely. But if you work with a factor of safety and within the building code, it should be okay. And now to get the nodes to display, it's once again, it's a Visibility Graphics override setting over here. And there is where we can go to the annotation categories and we search for nodes. Not annotation, on the analytical, and there we'll find our analytical nodes. So once we switch on the analytical mode, they'll display on the screen. You can switch off the line thickness and you can see them more clearly, and there you can see the analytical mode. Once you click on an analytical mode, there's 3 elements that come together over there. You'll see whether it's connected or not. You have some ability to modify the analytical mode. Depending on how you model, you'll find that they might sometimes not connect. Then you can go and have a look either at the the way in which this is the top alignment and the top extension method. You've got some control over that. It's projection. And if you do switch it onto the projection, then you'll see that you've got a choice between your location lines, the center of the element, or grids, or however it is that you want them to connect. So that's part of it. The other part of it is within your structural settings. So if you look at your structural tab, there's your structural settings, and within the structural settings, there's a few things that you need to do. One of them is to look at your, you've got your symbolic representations, your load cases that you can set up. I think you guys will be better with that than me. And then also your load combinations, if you're looking together, your analytical model settings. And this is where the tolerance of the model. So if you want those nodes to automatically connect, depending on the situation that you find yourself in, then you'll have to set these tolerances so that those nodes can automatically try and connect to other elements. So this is something to look at if you are setting up the analytical model for Robot. Just make sure that you've got your tolerances set so that you stay within your acceptable engineering approximation. You can tweak that over here to start generating errors for you if you're far away or so on. You can also automatically check whether the members have got support. In other words, are they supported, or have they got a boundary condition applied? And it will warn you if you are drawing an element without a support. It might get to irritate you, so you either check it after, and then you've got your boundary conditions as well. And these are families that you can load in. So those are the structural settings. And then somebody mentioned Rebar. I just want to show you that as well. You've got some Rebar settings as well. You've got Rebar cover settings, reinforcement settings, and reinforcement numbers. The reinforcement settings, note importantly that if you want to include the hooks and or the heat treatments within the shape bar definition to get it out onto a schedule, you would have to set that at the beginning of the project. It's very important, because if you don't, then you'll have to delete every single piece of rebar in your model before you can change this setting. So decide at the beginning of the project if you want to include hooks in the shape bar in the rebar definition, or just the heat treatments as well. So that's a sort of a basic setup in your Revit model. Your loads and your boundary conditions that you'll find on your analysis tab, is your analyze tab. You'll see on the left hand side that you can create some boundary conditions. Typically the boundary conditions include things like points, lines, or area conditions, and then and also what sort of state that would be: pinned, roller, user, or fixed. So that's a typical sort of way in which the analytical model is set up. And then it also includes your loads that you can create, area lines, line, posted on a point, posted line, and so on. So you've got lots of ways in which to do this. So what I've done over here is just to represent something heavy that's pressing down an area load. So maybe a piece of machinery that is standing flat on this something like a water tank or something like that, that's sitting on top of, sort of just raising it and giving it a bit of a pressure head. Here's where it is. And then you just applied the area load to it. It's pretty simple. You set the work plane on which you're working, and then you draw in the load. You can also do that from a plan view. If you get something like your plan view, the view range of analytical, just put the cut plane 1000, you should start seeing it. Down to associate level -1.5. Okay, so here you can see your area load sitting on top of your floor analytical model, and there you can see I've just applied 20 kilonewton-meters pressing downwards. And the idea is now that we want to get this model through into a robot. And so how do we do that? Well, you can do that live if Robot is open. Then Open quickly. And there's Robot. Okay, so we've got our analytical model, and then we're going to push that through into Robot. This is the same model but shown in 3D. This is Robot. You can start off with a blank project. There's something that kind of looks like what I'm doing. I'm not overly familiar with the Robot interface, so excuse me if I'm not an expert with this, but this would be your equivalent of Sumo. I know there's a lot that you can do with Robot. You can even input actual seismic recordings to go and shape the building around a bit. And of course, the larger the building becomes in the finite element analysis, you can set the FEM mesh size. You can apply loads within this platform. You can add members. You see on the right hand side there how you can do your bar selections and your stealing on the member design. There's a lot that goes on here that I don't understand. Unfortunately, it's not what I do from a day-to-day perspective, but this would be the equivalent of your Sumo. I know when you use Sumo, you have to model it up in Sumo, independent of Revit. There's no interaction between the two. So this is really what the advantage would be for you, is if you have your Revit model, then you would be able to go to your robot structural analysis, and then you would be able to do a robot structural analysis link. Within this link, we'll send the model. We can do a direct integration, we can run it at the same time, or we can send an intermediate file, which would just be a file that sits. So if it's a heavy file, for instance, then you wouldn't like to have it open within Revit on your computer and open within Robot at the same time, because it might just be too heavy for your computer to handle, too much RAM, too much processing power. And so you'll send it out into an intermediate file which sits there. So you can send it out into an intermediate file, let close Revit, open the Robot, and then read the information backwards and forwards using this as a sort of a placeholder for the information. The information can also go directly, and in your send options you'll find that you've got some of these settings that you can use, including you can export steel connections, reinforcement projects, beams, columns, spread footings, and so on. There's a lot that you can do. Again, I don't do this from a day-to-day perspective, but this is really where it starts. Okay. And that will then export information into Robot. You can see it's a direct link between the two software. You don't have to remodel the software. Now, because I've used the very specific, there's no errors. If there was an error, it would pick it up. So typically the sort of error that you might find, you perhaps know if your minimum CPU RAM is able to handle these programs simultaneously. No, I don't. I don't know what the minimum is, but minimum, that's a relative answer to me. If I can answer it differently, Marcus, just from a Revit modeling perspective, I can already tell you that depending on how large the building is, if you've got this computer here, for instance, on a sort of a medium-sized building, this computer couldn't handle it anymore after a week's worth of the guys putting up a file that's 600 megs and it would crash. So no, but you're welcome if you want to have a guideline. I always say you should sort of overspec if you can. So I would say look at Autodesk, Revit, Robot. Hardware requirements, system requirements for Autodesk Robot structural analysis. Here we go. This is now coming from 2020. It should be pretty much the same, so we can see already that okay, it does work on earlier versions. But 2021 might be different. Minimum 8 gigabytes of RAM. But to my mind, that's already too little. The processors, so not too much information. It doesn't look too heavy. When it comes to Revit, it's much more specific. So you can look this up. Yeah. Well, it depends. You say 32 gigabytes, and I agree with that, just from a system perspective. And what I can relate to you is that a relatively large model you'll be able to handle with 32 gigabytes. 16, yeah, it's 16, depending on the size of the model, is too. It's not big enough. 32, I would say, would do it in most of the cases. You'll see over here that if you go to a sort of more heavy, large, complex models, 32 gigabytes is recommended, quite right. I would go even more. I would go 64, but the reason for that is I showed you that Dynamo also interfaces with these products. So I can give you an example, for instance. So when I automated against this building over here, it was one of the buildings that I was involved in. I used to write Dynamo scripts to try and help the supply chain out with this building. You can see it's the largest hospital of its kind in the world, and what I would find is that if I ran Dynamo on these large models, there would obviously not be one model, there's various models, but when I ran Dynamo on these models, the computer would use up all of the RAM for about 20 minutes at a time while the script ran against the model. So if you are going to be doing automation using Dynamo, then I would go so far as to say forget the 32, go for 64. If you are going to get into automation, then even go with 128 because Dynamo uses only RAM. That's what it uses. But it's not going to be an issue in this case. So 32 would be perfect. I agree with that. And also Revit loves fast processes. So you'll find that typically when you're working with Revit that it won't use multi-core processing, only when you render, but it loves very fast processes. So the faster your processor is, the better for Revit. And that will make it into a nice responsive computer and also solid state M.2 hard drive. So all of those things come into play. So you can find that there's the little model that we've created. It's obviously not the largest hospital in the world, but it's indicative of what we can do. It's just going to take an enormous amount of computing power to be able to do that. And there you can see that the elements within Revit, the supports, the beams and columns, as well as the floor, as ported through into Robot. And there you'll find these, the load as well. Like I said, I'm not overly familiar with this interface, but essentially what must happen over here is that we need to do an analysis. You'll find that on the analysis toolbar over here, you've got your analysis types, and you can also do your calculations, the sorts of analyses that you can do in analysis type, structural model, load to mass conversion. You can do code checking in here. There's an enormous amount of stuff that bucking deformation. So again, more suited to a structural engineer than a modeler like me. I did mechanics of solids in the second year when I was in, I don't know, 2000 or something like that. So although I did quite well in the course, I didn't exactly become an engineer. But that's what you guys are. And so you'll know more about this than me. The analysis itself, when you run it, you'll find that it will run the calculations. And there's much more that you can do over here. You can set what sort of meshing you're using. You can modify the mesh. There's an enormous amount of stuff that you can do here, things that I don't understand. I understand it in principle, but not in detail. So that's the, if you go to the, I just want to refer you to the help as well. Typically what you'll find is that the Autodesk help files are brilliant. So I don't want to give you a webinar on the help file, but I know that when guys are learning software from the start, this would be the go-to. So there you can see how to design some frames in 2D and 3D and so on, how to run an analysis and explore the results. And there are actual tutorials that you can run to do this. Right? There are also, you can do a course, how do you say, long distance course with us or something like that. There's Robot Advanced Steel integrations. How do you go from Robot to Advanced Steel? How do you go from Revit to Robot? That's all in here. So this would be a great resource for you to start with. I know Autodesk puts an enormous amount of effort into their help files, and it's essentially a textbook that you can follow if you're able to teach yourself. Then this would be a good place to start. I just fiddled around this morning, so once the analysis is done, then you can see over here that you can have a look at your results. And on the results, you'll find you can get some diagrams and maps and detailed analysis as well. So you can get feedback in your robot itself. We'll just check all of these on quickly. There you can see the analysis results, your bending moment diagrams, shear force diagrams, your reaction forces. So this has now been calculated for these members. You should be able to switch the members out as well. If you wanted to model, if it wasn't sufficient and you want to make it larger, you'll be able to change them out within Robot itself. Because of those shape codes, it's in the database that's inside here. And you can also open it in a new window if you want. And that's the essence behind it. I know we're running out of time here, so I may be being caught short. But once you've run the analysis within Robot and you've done the modeling that you want, or changed the sections, or done the code checking with all of your elements, then you can, well, what I usually do is I just save this anyway. So I'll save as. I can save it as a Robot file. Let's give that a new name. I ran through something like this earlier this morning quickly. And the other part of it is on the you can then integrate that with Autodesk Revit structure. There's also some Inventor capability over here as well, it looks like. I'm not familiar with Inventor. I'm on the AEC side, but if you are designing an Inventor, it's there as well. And then there's the Autodesk Revit structure. So on this integration, you can ask to update the model as well, or send the model and results. So I'm going to update the model. That means that you'll be changing elements that you've changed out in Robot in the other. And then also, do you want to do that as a direct integration or save the information out into intermediate files if you don't have both programs at the same time? And again, you've got some options over here if you want to put the steel connections and reinforcements and so on. And then once we do that, maybe just before we do that, you might, sorry, there you go. Let's just go for it. Okay. So what that does now is it's writing the information back into Revit from Robot. And what's also nice about this is from a design perspective, you'll be able to see the information in the Revit model. So just waiting for this to run through quickly. Here it comes. And it says it completed successfully. I think maybe just for interest's sake, if we go to the structural model, then you can see the geometry. You can switch the results off quickly. I'll switch these off. Okay. Let's have a look at the steel design. Let's see if we can have a look over at the sections with gravity. Oops. Just maybe verification. There you'll be able to write columns, and you'll be able to draw columns with beams maybe. So let's put this beam across on that work plane. Save. Let's just update the model as well. You see if the beam comes through. Here's the type of beam that it's putting in. You see that it picks it up from a database. It's steel beam. It's using that UC type. And then let's save this file and write it through onto Revit. I'm going to update the model. Seems to have. And so I've obviously done something wrong within Robot there, but yeah, you can. I know that you can model within Robot and then after you've put it in, you can also visualize the results. Where does it disappear to? We switched it off, of course. So just switch it back on quickly. It's all live, and we bring it through. And update the model. And send the results as well. Okay. So there we can see the beam that came through. I actually did this morning, so let's just apply this. Apply. Unselect that. Apply. Start around this again. Sorry, this is turning into a bit of a runaround. But results diagrams. Let's just run this quickly. Okay. Okay, so for some other reason this is now not showing me my results, which is strange. This morning I did actually have the results coming through, but what it does in Revit is it will show you the results in Revit superimposed in a viewer over here. And just do that. Here's the action forces. Okay. Let's try this. Give it one last chance before we give up. No. Let's have a look at this element over there. Yeah, so it's not actually showing me my results manager at the moment, which is very disappointing. I had it this moment. Maybe I can just show you an image of what that looks like. There you go. Okay, so within Revit, but you'll find that this is now not the robot interface, but the Revit interface. That over there will light up. And then what you'll see is you'll see the results showing within Revit itself. So when you're busy designing, you'll have this gauge key showing you what stresses and strains there might be over there so that you can design within your Revit model to maybe add some extra support in here or whatever it is, how you would like to design. So you'll have the option to design either in Robot or within Revit. That would be available to you. And of course, this visual representation of your stresses and strains within Revit itself will help you to design within Revit. Yeah, so very disappointing that I couldn't get this to work right now. Something I got to work this morning. The results obviously didn't come through. I don't know why. That's really the sort of workflow between the two, that you can go from one file to the other. You can put some extra members in forces. You can handle them here as well. So you find your loads analyses that will come in over here, your code checking, your design options. You know, there's a lot that's happening over here. I see that we've got a frame generator that you can use, and then there's a community as well if you want to discuss these ideas with other guys. So, you know, we've really only scratched the surface. But like I said, with the help file, that would be a good one. Then, yep, you'll then see that within Revit, an update, and when you can write it forwards and backwards. Got to go. Clapped. It's great having you here. Thank you very much, and have a great. Yeah. have a look at the ASI. I think we're very useful for a junior designer. I'm a civil engineer with some experience in structural design, but civil engineers currently working in the majority. Structural design is using Procore and Sumo. We've both been using Revit for about a year now, and it looks like Robot structural analysis can be very useful in the Revit well. Yes. So after downloading the full Aec collection, it will be a good starting point for me to learn the program while doing small design. Do you agree? Yes, but I would go further than that and say that if you remember, this also works on if I might just take one more minute of your time. I don't know if you need to run. Just let me know if I'm wasting the time here. The sort of model, smaller project would be a good start, but I know from, I would always just, I don't know to go. Okay, I would always just have a look at something. You know, this is on cloud. So I know, for instance, that I've had design collaboration. Here's my structural model. So this is a structural model that I'm playing with at the moment. It's one of the disciplines that I'm playing with, and this is I sort of work through these models. So if you have a structural model, for instance, you will know from yourself that everything is interconnected. When you do a finite element analysis, and everything must be hooked up to each other, right? You can't sort of separate the building into two parts, subject it to stresses, and expect that to work in a sort of linear, or it does work linearly, but it's very difficult to transmit the forces. You might find out, okay, it's got X and reaction forces and moments, and sort of try and jipper, but typically the building must be one structure for you to properly, it's like heating and cooling loads analysis. It's the same sort of a theory behind it, that everything must be in one model. And what I find is that you learn and you get questions when you start modeling up these projects. So and you start learning on how to handle them. But what's always important is just to have a critical look at the analytical results as well. Just to say, okay, we need to understand whether what the results we're getting is that rational, does it make sense? Do we have a confidence interval that we can say, right, I'm relatively certain that what I'm seeing is good, and I'm sure you're familiar with that from engineering. The typical thing that they say in engineering is to, a little knowledge is a dangerous thing, which is so true. 3D views, if I can just have a look at the analytical model that I might have set up over here, AM there. So it's quite a large model, and this is where the sort of limit of the computer gets pushed. Because as a structural engineer, you can't, this is not, I'll sort of tell you what this is. It's just a sort of a skyscraper that's the same sort of size as something like a large building like the stock exchange in Johannesburg, or that kind of size building that this building represents. And some of the tricks that I'm learning as I'm going along with this is that that you can work in groups, and when you do floors in groups, for instance, if your beams and your whatever is the same all the time, then they do connect the nodes as well, which is great. And but where it becomes complex is with things like parking ramps and so on, and that's one of my regions of interest that I have to spend time on, is to use Robot to model up the parking ramps for this building, simply because Revit doesn't do that very well, like I said. So one would be excluding the structural or the concrete part from the analysis, and so there's finer points to it, which again one will find. I know there's a class in Autodesk University that specifically deals with it. I saw it somewhere online. There are some good textbooks for Robot as well. If you're interested, it is the tool that would be wielded by a structural engineer like yourself. It's not the tool that a modeler like myself would necessarily work with a lot. But here, yeah, there are some good handbooks out there. There's an entry-level sort of thing that we can give you, and teach the basics, but then I know there are some international books that have been written about the subject. So yeah, you can see the computer is already struggling, right? And these are the sorts of things that I'm learning as I'm going along, is how does the computer manage this? So you can see my CPU is almost maxed out, memory is almost maxed out. So I would go from minimum 32, maybe 64, really fast processing. This is of course a laptop, so it's it's the sort of work laptop. It's not a performance machine. We do have a performance machine, so if I really wanted to play with this model, I could get going with it. The GPU is not getting taxed too much. It's a small GPU, so that's not really an issue. And then here you can see what the structural model looks like. So it's interesting when you start setting up these models to see how do the walls and the floors and the columns and all, how do they interact with each other. And of course, if you crunch something like this within Robot, it's also going to take a lot of computing power. So I would sort of look towards a really good computer. The same, I'm running over time here, so the same sort of workflow also works with, and maybe I can just, I don't know if you guys do fabrication, but Autodesk Advanced Steel is used on things like, yeah, 64. You don't want to struggle, no. Used for smaller project files to use shop drawings, yeah. If you do shop drawings, then have a look at this Advanced Steel product. It is the most amazing software. I've actually worked through a course like this with Advanced Steel, and if you know AutoCAD, then you won't struggle with it. But this goes too fast too, and you can see dynamos. But all the joins that you can do within Revit, it will port backwards and forwards. So if you have your joins in your Revit model, it will also show up in Advanced Steel. But in addition to that, you can set up custom joins within Advanced Steel that will be recorded as information, but won't show up graphically within Revit. It will just have a symbol to it. But within Advanced Steel, it will actually show that up to you. It will have the number of bolts, the washers, the spacing, the webbings, the welding symbols, through to the CNC files that you can spool it onto CNC machines for water jet wood cutting or whatever it is that you need, the sort of surface finishes, anodizing, powder coating, whatever it is that you need. And all of the information coming through, and they've built that on top of AutoCAD. But what's nice about it is it also ports the geometry that you do within Advanced Steel. Just like with Robot, it reads it back into Revit, and so Advanced Steel also reads it back into Revit. So those three programs together, that's going to meet all of your requirements, and you'll see also on Autodesk University that they've got these three programs working in tandem with each other. Looking forward to it. Actually, do you have a good December? Will you send a recording of this course? Yes, I'll be posting a recording onto the website that we've got. You'll find it in mgff.co.za. We've got some other webinars up here as well if you're interested. mgff.co.za. And then just search for webinars over there. But I will send it on to you as a direct link as well, and you can have a look at that. Yeah. So thanks very much for attending. I appreciate that, and I hope you have a wonderful Christmas. And yeah, so when you get over here, just search for webinars. I think you should find a link to it there. View past webinar recordings, and then you'll find that both from a manufacturing and AEC perspective, you might find some things that you might be interested in. We do some webinars all the time, so but yeah. So I hope you have a great Christmas period, and regards to your family, and keep safe. Right. Thanks then.